What's going on, guys? Today we're going to talk about a combination of absolute value functions and at the same time piecewise functions, right? So we're going to kind of combine both concepts together a little bit and learn what the deal is with them. So, real quick scenario, it just says Michelle likes riding her bike to and from her favorite lake on Wednesdays. She created the following graph to represent the distance she is away from the lake while biking. So that's important. This graph shows, as you can see, even bigger on the right over here, the y-axis is distance, how many blocks she is, and then this is time down here, right? So time keeps going no matter what. So hopefully you realize the graph keeps moving to the right no matter what she does because the minutes keep passing no matter what, right? All right, so very simple. The very first thing I want you guys to do is write some observations. So problem number one just says, interpret the graph by writing 3 observations about Michelle's bike ride. Okay, so go ahead and pause the video, and I want to see you write down 3 things that you notice. Okay, what are 3 things that you think are happening or that you notice? It can be simple things, right? But try and relate what you say to the actual context of the problem, meaning to the bike ride and the distance and the time and all that. Okay, so go ahead and pause and do it. All right, so, a few things you could have said is maybe you noticed that she didn't actually start her bike ride at the lake. So it says she likes to ride her bike to and from her favorite lake. But where does she start? We don't know. But maybe this is her house, right? Maybe up here is her house, right? So you notice that she ends the trip at her house. Maybe she starts the trip at her house, which means this down here must be the lake, right? So once she gets there, it's the lake. Okay, maybe you said it looks like it takes 3 minutes for her to get from her house to the lake, or 3 minutes from her to get from the lake to her house, right? So this distance is 1, 2, 3 minutes. And in that time, she got to her house, for example, right? So any random observation like that is fine, but I do want you to know that this spot right here is whenever she reaches the lake, and up here should be whenever she reaches her house, right? So now it says write a piecewise function for this situation. So you should have on your paper your 3 things that you listed, your observations. I gave you a couple, but hopefully you have some of your own. And then the next one, after you do that, is going to be your actual piecewise function. So let me just zoom out just a hair. And so you could actually put your piecewise function in here, right? So I expect to see 2 equations with 2 domains and all that good stuff. It says to go ahead and leave your equations in point slope form using the point 30. So it specifically tells you what point to use and what form of linear equation to use. Even though you might look at this as an absolute value function, because we just talked about that very, very recently, it wants you to put in the 2 equations that make up this graph. Okay, so go ahead and pause and do that now. All right, so hopefully you guys had a chance to get these equations. And here's kind of what I came up with and I want to talk about, right? So first of all, if your equation here said y minus 0 equals 2 times x minus 3, that's okay. But subtracting 0 doesn't do anything. And if you add 0 to both sides, it doesn't actually change anything. So you'll notice on my equations, or whenever you actually simplify it, the 0 goes away, and you should actually get these 2 equations that I have here in red. Okay, so y equals 2 times x minus 3, y equals negative 2 times x minus 3. The first one, I actually put them in opposite order. I should have put them in the other order, so that's my bad. Let's actually fix that. All right, so now I changed positions, right? So the first graph, remember we always read left to right, shame on me. The first graph should have been this one, right? And the second graph should have been this one. So we just talked about that. So the negative side first is a negative slope, and it goes down 2 over 1, down 2 over 1. So that's where the negative 2 comes from. And then we used 3, 0, right? That line stops at 3. So it's saying that x is everything less than or equal to 3, which some people might have put this. From negative infinity to positive 3 is the same thing as that. Okay, so if you had that or if you had the 0 next to the y, it's okay. All right, the next equation is the same thing, but it's got a positive slope now. Let's make this a different color. We'll use purple. It's got a positive 2 slope, but still has the same point, 3, 0. And it's where everything is greater than or equal to 3. If x is greater than or equal to 3, so anything from here over is that, and anywhere from here over is that, right? So now you can kind of see the colors. And this was, you could have also put 3 is less than or equal to x is less than infinity, but it ends up just kind of looking like this. So either one of these are okay for that, and then either one of these were okay for the orange, right? All right, so hopefully you guys got that. This particular piecewise function is called, I'm looking at number 3 now, is called linear absolute value function. What are the traits you are noticing about linear absolute value functions? So for number 3, just write something that you notice. Okay, pause and tell me. Okay, what do you notice? Pause. Okay, hopefully you wrote something about it being exactly the same on both sides. So the equations are the exact same in your piecewise. The only difference was is you had one slope that was negative and one slope that was positive. Okay, that's the only difference, and it is literally an absolute value function. All right, so part 1 was realizing that we can make a piecewise function is the same thing as an absolute value function in a sense, right? All right. All right, so now we're going to speed it up just a hair. Part 2 says, in this part of the task, you will solidify your understanding of piecewise and use your knowledge of transformations to make sense of absolute value functions. Follow the directions and answer the equations below. So the very first thing I want you to do, and you could do it in Desmos if you want, if you don't know, but think about it. How would you graph the function f of x equals x, or just y equals x? Okay, and if we graph a line, we usually say, okay, y equals mx plus b. Okay, here's my y-intercept, here's my slope. So what is the y-intercept and slope of this function, right? Well, this is the same thing as saying f of x equals 1x plus 0. If you multiply by 1, you change nothing. If you add 0, you change nothing. So this is the same thing as just this. So now going back to this, can we graph a function, the parent function that has a slope of 1 and a y-intercept of 0, right? Then number 5 says to graph a new function, the g of x function, and the g of x function is the absolute value of your original function. This looks super intimidating, but this just equals this. So really, g of x equals the absolute value of x, okay? So now on a set of axes, you're going to have the g of x function and the f of x function graphed on the same set of axes. It might be helpful to do it in Desmos, or do it with colored pencils on your paper. Would be really nice, okay? The question is for number 6, so I should see the graph for number 5. Number 6, explain what happens graphically from f of x to g of x. In other words, what is the difference, right? I'm going to actually put this on Desmos for you guys. All right, so here it is. Let's just make this one not a black one, we'll make it red. Okay, so we have one red one and one blue one. Let's take away the absolute value. And by the way, I can probably, let's see if I can make a table of that. Oh yeah, cool. Cool, so there's the table of the absolute value function. Not sure why the line's not going through it now, but that's drama. Maybe because I just told it to be a point only. I don't know. Whatever. And I'm just going to rewrite it then. So let's do absolute value of x. And that's how you do an absolute value. We're going to make this red too. We'll show it who's boss. All right. So right off the bat, I want you to notice that on the line itself, the blue line, that is the original f of x graph, right? So that's how you should have graphed it. Up 1 over 1, up 1 over 1, up 1 over 1. But what happens with the red graph is that we change at the vertex. Okay, we don't go up 1 over 1, up 1 over 1, because once we get here, we would have to end up here, right? But we don't. We come back to the positive. So explain what happens graphically. The graph ends up going back up, right? Once it gets to the negative side, the graph goes back up. Write the piecewise function for g of x. So G of x is there, this red graph that you guys have, right? Write the piecewise function. Okay, I'm looking for something that looks just like this, right? It's not going to be these exact equations, but it's going to look very, very similar. That's what it means whenever it says to write a piecewise function. You have to give me both equations in both domains. All right, next question says, that says, write the piecewise function, explain your process for creating this piecewise function, how it connects to your answer. Okay, you could kind of skip. Don't skip that. I want to say a couple sentences for that. What was your process? How does it connect to your answer all the way back in question 3, right? So go back and relate that. All right, number 8. Complete the table from -4 to 4 for f of x and g of x. So good news, if you toss them in Desmos like I did, it will make the table for you. And you can literally type in whatever values you want. See, 1, 2, 3, 4, whatever, and it will tell you the answers over here. So it'll make your table very, very simple. Or you could just plug them into both equations. So I recommend just doing it in Desmos. Okay, in fact, here's the answers from -2 to 3 for f of x. And here's the answers, well, was the answers, but from -2 to 2 for the absolute value. So you have most of the answers already if you just go to Desmos and type in these 2 equations. By the way, if you do absolute value, make sure you type in ABS and then put your x in parentheses, okay? All right. Now we're going to get all the way down to part 3. Okay, all the way down to part 3. And part 3 is where you have to do a little bit more work. So part 3 says, the graph below is another example of an absolute value function. The equation of this function can be written in 2 ways. So here's one way you can write it. F of x equals the absolute value of x plus 3. And then the other way is the piecewise function, where x plus 3 is the linear equation, but one of them is positive and one of them is negative. And you can see the domain here. The negative goes from where x is everything less than -3, so on this side, and the positive is everything that's greater than -3, which is on this side. How do these equations relate to each other? So I want to see on number 9 a couple sentences, right? How do they relate? I literally just talked about it. Okay, so talk about how these 2 equations, this one and these ones, relate to each other. All right, 10, 11, and then the rest. It says below are graphs and equations of more linear absolute value functions. Write the piecewise functions for each. See if you can create a strategy for writing these, okay? Let's just do number 10 together. Okay, if you're still stuck, let's do number 10 together. If not, pause and see if you can do it and see if you can get the right answer. And this is the one that I'm going to go over. Okay, so pause if you need to. Okay, here's the original function. We can see where the vertex is, right? 1, 2 is the vertex. Which means my axis of symmetry is x equals 1. Okay, this tells us right here, by the way, this helps us with our domain. You'll see in a minute. So now I'm going to write 2 equations, right? 2 equations for this. And the 2 equations is going to be the exact same thing. It's just going to be like this. First one I'll put in red. X minus 1, we'll put it in parentheses. Okay, plus 2. Okay, we could do that. And remember, this is my point in point slope form, 1, 2. Look where it is. So we're literally just using the vertex. And you'll see also our axis of symmetry. These are the 2 pieces of information that we use. So there's my vertex in use. The other equation is the same, but it's positive. So this is the negative side. This is the positive side using our vertex. And then what do we put here? So this thing is everything left of 1. X has to be less than, you could put or equal to 1, right? So right here on my graph, if you look right here where my mouse is, everything to the left of 1. Where did we get that? My axis of symmetry, right? This is everything greater than 1. And you can put the equal sign on 1 or on both of these, by the way. That's it. So if you get the vertex and the axis of the axis of symmetry tells you, or the x value of your vertex tells you how to do your domain. One's everything to the left, one's everything to the right. And then make sure you have your -1 first, your +1 second. So go ahead and do the same thing for 11, and then 12 is pretty much the same thing, but it gives you two equations and now has you graph them instead. And then number 14 actually wants you to write the absolute value equation there, like you've been seeing. So pretty much the exact same thing, but guess what? You're not going to have it negative, and you're not going to have a domain anymore, okay? 15 is the very last thing you're going to do. It just explain your method for doing the following. Okay, explain your method for doing the following. So you're going to have an A, and you're going to say, okay, my method for writing piecewise linear absolute value functions are, and just give a couple sentences, B a couple sentences, and C a couple sentences, okay? Kind of a long assignment, guys. I'm going to give you 20 points for it because I think it's worth it. And so if I don't mark it 20 points, remind me, and I'll make sure to change that, okay? So that means if you watch the video all the way to the end, you'll know, and you can remind me, like, hey, make sure you make this worth 20 points, because if you do it, it's going to help you, okay? It'll help you more. It's like doing 2 assignments if you do it. All right, guys, let me know if you have any questions. Have a great day.